Hello everyone and welcome back to our channel. In today's video, we're going to explore one of the most powerful functions in PySpark, the withColumn function. Whether you're adding new columns to your data frame or modifying existing ones, withColumn is your go-to tool for transforming data efficiently. We'll walk through how to use this function to create new columns, update data based on calculations, and apply transformations all in just a few simple steps. If you're ready to make your data frames more powerful, then stick around, let's dive in. Introduction to the withColumn function. The withColumn function in PySpark is a versatile and powerful tool that is used to either create a new column or modify an existing column within a data frame. This function is particularly useful when you need to transform your data in as though you base by applying some logic to an existing column or by creating an entirely new column that's derived from other values in the data frame. For instance, you might use with column to add a calculated field such as increasing salaries by a certain percentage or to transform an existing field by applying functions like arithmetic operations, rounding or string manipulations. The with column function takes two arguments, the name of the new or modified column and the value or transformation that defines it. If the specified column name already exists, with column will overwrite it with the new value. Otherwise, it will append a new column to the data frame. This makes the function highly flexible, allowing you to apply a wide variety of transformations directly without having to perform additional steps. Whether you are creating new metrics, standardizing existing fields, or performing data type conversions, with column provides an easy way to enhance the structure and value of your data, making it a go-to method for data engineers and analysts working with PySpark. Basic syntax. So, the basic syntax for using the withColumn function in PySpark is dataframe.withColumn column name. This syntax includes two key parameters that are essential for the operation. The first parameter, column name, is the name of the column you want to create or modify. If the column name specified already exists in the data frame, withColumn will modify the existing column with the new values derived from the provided expression. If the column does not exist, it will create a new column with the specified name. Second parameter expression is the transformation or calculation that defines how the new or existing column should be generated or altered. This expression can be a simple value calculation involving other columns or even a more complex function or transformation applied to one or more existing columns. For instance, you can use expressions like adding values, multiplying columns, performing string manipulations, or even applying user-defined functions to modify the data. The flexibility of the withColumn function allows you to quickly create new insights or modify existing data without the need for complicated steps. It's a crucial part of working with PySpark dataframes, enabling efficient data manipulation and helping to enrich your data with new features that enhance your analysis or downstream processes. How it works. The withColumn function in PySpark operates in a straightforward yet powerful manner when it comes to creating or modding columns in a data frame. If the column name specified in withColumn already exists in the data frame, the function will override the existing column with the new values derived from the provided transformation or calculation. This makes it easy to update data or apply changes to an existing column without creating additional redundant columns. On the other hand, if the column name does not already exist in the data frame, withColumn will create a new column with that name and populate it with values derived from the provided expression. This flexibility allows you to enrich your data frame by adding entirely new columns based on existing data or custom calculations. Overall, withColumn is a powerful function for transforming your data and preparing it for further analysis. Whether you need to derive metrics, normalize, For standardized values or apply custom transformations, with column allows you to efficiently reshape your data frame in a single step. Its ability to either create new columns or modify existing ones makes it an indispensable tool for data preparation, allowing you to handle data transformation tasks effectively and streamline the workflow of working with big data in PySpark. Practical examples: 1. Adding a new column with a simple expression. In this example, we are working with a PySpark data frame D8 that contains employee information, including columns for employee underscore name and salary. We create the data frame using the create data frame function and provide a list of tuples representing each employee's details such as their unique ID, name, and salary. This structured representation makes it easy to analyze and manipulate the employee data. To add a new column to the data frame, we use the withColumn function to create a column named new underscore salary. The new column will contain values that represent a 10% increase in each employee's current salary. The expression used to calculate this new value is df.salar multiplied by 1.1, which multiplies each employee's salary by 1.1 to account for a 10% raise. By using withColumn, we can easily apply this transformation to all rows of the data frame, creating a new column that contains another update salary figures. Finally, we use the dot show method to display the updated data frame. So you now include the new underscore salary column and also the existing columns. The output will show each employee's ID, name, original salary, and their increased salary. This example highlights how withColumn can be used to enhance a data frame by adding new information derived from existing columns, making it a powerful and flexible tool for data transformation. It allows you to enrich your dataset with additional features or metrics that are relevant to your analysis or decision-making processes, all in a concise and efficient manner. 2. Modifying an existing column. In this example, we are working with a PySpark data frame div that contains employee data, including columns for employee underscore ID, name, and salary. We create the data frame using the create data frame function and provide a list of tuples representing employee records, with each tuple containing the employee's ID and current salary. This setup allows us to easily work with structured employee information. To modify the existing salary column, we use the withColumn function. By specifying salary as the column name, we instruct PySpark to override the current salary values with new values calculated using the expression df_salary 1.1. This expression multiplies each employee's salary by 1.1, which represents a 10% increase. Since we are using withColumn, with an existing column name, the original salary values are updated directly rather than adding a new column to the data frame. Finally, we use the dot show method to display the modified data frame, which will include each employee's updated salary after applying the 10% increase. This example demonstrates how withColumn can be effectively used to transform existing data by modifying a column in place. It allows for concise and efficient data updates without having to create redundant columns, making it particularly useful when you want to make changes to your data directly and keep the data frame structure simple and clean. 3. Adding a column based on a conditional expression. In this example, we are working with the PySpark data frame D wave that contains employee information, including employee underscore name and salary. We create this data frame using the created data frame function, which allows us to represent the employee details in a structured manner, making it easier to manipulate and analyze. To add a new column named bonus underscore eligible, we use the withColumn function along with the when function from PySpark. The when function is used to create conditional logic for determining the value of the new column. In this case, we want to add a column that indicates whether an employee is eligible for a bonus based on their salary. Specifically, we use the condition when df thrive 100 true, which means that if the employee's salary is greater than 3,500, the value for bonus underscore eligible will be true. If the condition is not met, the dot otherwise false part of the code ensures that the value will be false. This new column helps us easily identify employees who qualify for a bonus based on their salary, providing useful information for further analysis or decision making. The .show method is then used to display the updated data frame, which now includes underscore eligible column alongside the existing columns. This example demonstrates how withColumn combined with when can be used to add new columns based on specific conditions, making it easy to enrich your dataset with new features derived from existing data. This type of conditional logic is particularly useful when categorizing or segmenting data based on certain criteria, helping you to create more meaningful and actionable insights from your data frame. 4. Using withColumn to create a column based on multiple columns. In this example, we are working with a PySpark data frame df underscore bonus that contains employee information including employee underscore name, salary, and name. We create this data frame using the created data frame function, which helps us organize the data into a structured format, making it easy to analyze and manipulate. Each row in the data frame represents an employee's details with columns that provide information on their salary and bonus amounts. To calculate the total compensation for each employee, we use the withColumn function to add a new column named total underscore compensation. This new column is defined as the sum of the salary and bonus columns calculated using the expression df underscore bonus dot salary df underscore bus dot bonus dot bonus. By adding these two columns together, we determine the complete compensation package for each employee, which includes both their base salary and their bonus. The .show method is used to display the updated data frame, which now includes the total underscore compensation column alongside the original columns. This new column provides a clear view of each employee's total earnings, which can be useful for understanding overall compensation, making comparisons, or performing further analysis related to payroll or financial planning. This example demonstrates how withColumn can be used effectively to add new columns derived from existing ones, allowing you to create additional insights from your data. By calculating total underscore compensation, you enrich the dataset with valuable information that helps in making more informed decisions regarding employee compensation. 5. Using built-in functions in withColumn. In this example, we are working with the PySpark data frame df that contains employee information, including employee underscore name and salary. We create the data frame using the create data frame function, where each row represents an employee's details such as ID, name, and salary. This structured representation allows us to easily perform various data manipulation tasks. To add a new column that captures the length of the employee's name, we use the withColumn function in combination with the length function from PySpark.SQL.functions. The length function is used to calculate the number of characters in the name column for each row. By using withColumn name underscore length def.name, we create a new column called name underscore length that contains the length of each employee's name. Finally, we use the .show method to be the updated data frame, which now includes the name underscore length column alongside the existing columns. The output shows the original employee information along with a new column indicating how many characters are in each employee's name. This type of transformation is particularly useful when you need to analyze or work with textual data, as it allows you to extract useful features from streams such as their length for further analysis. Adding such direct columns enriches the dataset and provides more details that can be leveraged for deeper insights, such as determining patterns in name lengths or performing data quality checks. Thanks so much for tuning in. I hope you now feel confident using the with column function to add and modify columns in your PySpark data frames. It's an incredibly versatile tool that will help you enhance and transform your data, making your analysis more insightful and effective. If you found this video helpful, be sure to give it a thumbs up, subscribe to our channel for more PySpark tutorials, and leave a comment if you have any questions or topics you'd like us to cover next. Until next time, keep coding and exploring the power of PySpark.